and I'm going to pour some of this water into this styrofoam cup. And then what I'm going to do, you want to watch very closely. We're going to do a little magic trick here. I'm going to put the styrofoam cup over here. And then as I rearrange these cups, watch very closely to where the cup with the water is, right? All right. So which cup has the water in it? And if you watch very closely, some of you will guess this one over here on the right side. So let's see. I'm going to see. I'm going to just pour some over my head. Nope. All right, which one do you think? This one or this one? Let's go with this one here. Oh, wow. No water in that either. It must be in the middle one. I think I fooled you, right? Did I fool you? I think I fooled everybody. There's no water in anything. So what happened to the water? Where did the water go? So the water has been absorbed by a chemical called sodium polyacrylate, right? And sodium polyacrylate that has this structure that's pictured right here. It's a polymer. It's a super water absorbing polymer that's commercially being used in baby diapers to absorb the urine from babies. It also has a couple limited studies that are showing it may be useful in dissipating fog as well. So it absorbs water, and it can absorb like up to 800 grams of water for 1 gram of polymer. Now 1 gram is 1 milliliter, so if this is 800 milliliters of water, 1 gram of sodium polyacrylate will dissolve all the water in this beaker right here, right? So that's a super water absorbing chemical. Now, if we look at this after it absorbed the water, let's just look at what's inside here. It's actually relatively safe. And it kind of forms this kind of gel-like substance. And that's kind of what it looks like, right? And it actually kind of resembles snow, right? So if you want a white Christmas and you live in a place that has lots of water, but not a whole lot of snowfall, well, sodium polyacrylate might be able to give you a white Christmas, right? So that's your sodium polyacrylate. Now, where does this come into play? In the movie Twisters, which just came out this summer, that was a pretty good movie. It was pretty action-packed. They actually used sodium polyacrylate to stop a tornado, right? And so now the question remains, is this actually legitimate? I mean, could we actually use this stuff to stop a tornado and thereby prevent thousands, billions of dollars, millions of dollars in damage to property and even stop loss of life? Right, so let's just kind of do the chemistry on here, and let's see how much sodium polyacrylate we're going to need to actually do this, right? So first of all, what we know that sodium polyacrylate can absorb 300 to 800 grams of water for every 1 gram of polymer. So that gives us kind of a definite ratio which we have to work with. We also know that tornadoes typically form from cumulonimbus clouds. And these typically contain about 15 to 25 grams of water per cubic meter, right? So we know how much water is in the tornado. Well, to know exactly how much water is in the tornado, we need to calculate the volume of that tornado, right? Now we're going to assume kind of an average sized tornado. Let's just make an assumption that our tornado is 2 kilometers tall and it's 1 kilometer in diameter, right? Given those dimensions, and we know that tornadoes are kind of cone shaped, so they kind of go up, they spin around, so it's a conical shape. Well, we can calculate the volume of a cone if we know its height and its radius, right? So the formula for the volume of a cone is pi times r squared, that's the radius, times the height divided by 3, right? So if we plug in our numbers here, I'm going to use a value of 3.14159 for the value of pi. And the diameter is 1,000 meters. The radius is 1/2 that, so I can use 500 meters. And then I'm going to square that, so 500 squared. And then the height is 2,000 meters, that's 2 kilometers. So 2,000 divided by 3, right? This will give us the volume in meters cubed. And I come up with the volume of our average size tornado of 5.24 times 10 to the 8th power meters cubed, right? So, if we take the volume of this average tornado and multiply it by the water content of our cumulonimbus cloud, we can, here's the volume of our tornado multiplied by 25 grams per meter cubed. Notice we're using dimensional analysis, so our meters cubed is in the numerator and the denominator, so that's going to cancel out, leaving us with 1.31 times 10 to the 10th power grams of water content in our average tornado, right? So how much polymer do we need? Well, we were given a ratio. We've got 300 to 800 grams of water for every 1 gram of polymer that's used. And that's how much it can absorb. For the interest of this calculation, I'm going to go with the maximum. I'm going to assume that it's 800 grams of water for every gram of polymer. Could be less. In that case, we're just going to need more polymer, right? But we're going to do our calculations based on 800 grams. We're also going to start with the mass of water, and we're going to multiply it by the ratio of water in the polymer. So here's our mass of water that we just calculated. That's multiplied by 1 gram of sodium polyacrylate per 800 grams of water. Notice how our grams will cancel out, leaving us with grams of sodium polyacrylate. That's 1.64 times 10 to the 7th grams of sodium polyacrylate. Now if we convert that to kilograms, just by dividing by 1,000, we see that we will need 16,362 kilograms of sodium polyacrylate. That's a whole heck of a lot of chemical, right? How are we going to store that, right? How do you store and transport 16K kilograms of a substance, right? So in the movie, they used standard industrial size barrels. These were 55-gallon drums. And so let's convert that to metric units. 55 gallons is 208 liters. And that converts to 0.208 meters cubed, right? These are exact measurements. I'm kind of rounding off to 3 decimal places of significant figures. So 0.208 meters cubed, right? We also know the bulk density of sodium polyacrylate. That's kind of labeled on the bottle when you buy it. And so that's 0.57 grams per cubic centimeter. Now, if we convert cubic centimeters to meters cubed, we know that 1 cubic centimeter is 1 times 10 to the 6th meters cubed. So if we just kind of do the calculation, we arrived at the density, the bulk density of sodium polyacrylate is 5.7 times 10 to the 5th power grams per meters cubed, right? Now, if we know the density, we know the mass, we can calculate the volume because we know that density equals mass divided by volume. I think we learned that in high school chemistry. That's fairly basic. Now, if we rearrange this equation, volume equals mass divided by density, we come up with, well, we take 1.64 times 10 to the 7th grams of sodium polyacrylate, that's the mass, divided by the density of 5.7 times 10 to the 5th power, and we get 28.8 meters cubed. If we divide that by the fact that we need 0.208 meters cubed per barrel, we can say that we're going to need 138.2 barrels of sodium polyacrylate, right? Now in the movie, the first time they stopped a tornado at the beginning of the movie, I think they had 6 to 8 barrels in a trailer at the back of their truck. That falls far short here. By the end of the movie, they used a slightly bigger trailer, bigger car, and I think it was about 39 to 40 barrels of sodium polyacrylate that they used. So again, the math isn't quite mathing here. They're going to need a lot more barrels of sodium polyacrylate. Then they're also going to need to be able to transport that to the site of the tornado, right? And so, is that logistically possible, right? Well, according to the Federal Emergency Management Agency, a tornado warning is issued when a tornado has been sighted or indicated by weather radar. And so the response time you're given to take shelter is 10 to 15 minutes. So that's not a whole lot of time. And you're basically finding shelter. How do you transport 138 barrels of this stuff to the site of the tornado in an effort to stop it? That's going to require some heavy lifting right there. We're actually going to need Star Trek style transporter beams, which don't even exist yet. Sorry, Scotty. But it's basically logistically impossible to transport all that sodium polyacrylate to a site where the tornado can appear any time, any minute, and very short acting, right? So the time is just not there, right? There's also another issue in the total volume of the tornado. We've got a total volume that goes up 2 kilometers. And we've got these tiny barrels of sodium polyacrylate on the ground, right? And so all that water needs to come out of that tornado in order to interact with the sodium polyacrylate so that it can be absorbed, right? So how do we do it? Now the movie did address that, right? How did they address getting the moisture out of the clouds? Well, they used silver iodide, and this is actually commonly used in cloud seeding, mainly in places where you've got a drought. You've got some clouds up there, you need to make it rain for the agriculture. So you seed the clouds with silver iodide. That serves as a nucleus for the condensation of water, and then those heavy particles are able to rain out. And so that's commonly used, but it takes about 20 to 25 minutes after cloud seeding. So again, we're a little bit past the response time in a tornado, and it doesn't completely dissipate the tornado. It may take 10 to 20% of the moisture out of the tornado, but it will not completely get rid of the moisture of those clouds, right? So cloud seeding, it's a nice thought, but it doesn't quite work out. The movie was pretty entertaining, though, and I did kind of like a couple themes in the movie. As an action-packed movie, it certainly kept you on the grip of your seat for times. I really liked the fire tornado. That was really cool when we were going through the oil refinery. I thought the acting was good. Daisy Edgar Jones, she was great as the character Kate, the scientist, some kind of scientist in there. Glenn Powell, of course, he was in Top Gun as well. But he was excellent, and the chemistry between those two really kind of developed. And of course, Anthony Ramos, that the chemistry between all three was pretty good overall. Did kind of miss Bill Paxton and also Helen Hunt to an extent. Of course, this movie was made not really as a sequel, but it was really made more as just a continuation. We've got different characters, different science going on, but still the same general themes in the original movie, which I thought was pretty good. One of the major scientific related themes that I liked was the fact that they illustrated it doesn't require a whole lot of money to do good science, right? And so in the film, you had some very well-funded corporate scientists And they had some expensive weather radars that they were using to test to get a better picture of the tornado. And this radar actually exists that could actually be used to, in the next several years, we might get better predictions of tornado formation. And so that science was real. And of course, you had the well-funded storm chasers. And then on the other side, you had the academic, less well-funded. It was actually a YouTube team. Well, I guess, those of us on YouTube, we actually kind of know what we're doing, right? And so we can actually do a lot of good science for not a whole lot of money, right? And so good science doesn't have to be super well funded. There's also that issue that with funding does come certain expectations, and those expectations may also have a hidden agenda. They illustrated the issue with the character Riggs, that real estate developer who was trying to gain research into what communities might be affected by a tornado so he would have cheap real estate to buy people out of. And so that was one of the major themes, one of the cautions you have to be careful of when you accept funding in any situation. Another major theme that I liked is safety. So safety is always important. I've actually recorded this video 3 times because the first 2 times I forgot to wear my safety goggles. Safety is kind of an important factor in any experiment, whatever you're doing. Storm chasing is certainly a very exciting activity, and it can yield good data because, you often have to go to the site of a tornado to learn more about that tornado, right? Yet they're also completely devastating to communities and the people that they affect. And what I really appreciated in the movie was the attention they gave to the human factor and the question of, is all this death and destruction worth the data you're going to get to fund your next grant, right? And I thought that was a very important component of that, of the movie as well. So overall, I thought it was a pretty good movie. I actually watched this movie myself. I didn't watch it in the theaters. I actually watched it a couple of weeks ago. I'm traveling across the country on Southwest Airlines. Thanks, Southwest. I'll give them a shout out. They have the movie on their in-flight movie list, so I was able to watch that literally while flying over the state of Oklahoma. So I was kind of on site, if you will, maybe 35,000 feet above site. So that was kind of exciting. Lastly, I did want to give a little bit of a memoriam right here in Cookeville. Tornadoes can affect your community, literally any community, wherever you are. Now, there is Tornado Alley where the film was centered around, but right here in Cookeville, in Tennessee, right before the pandemic of 2020, we were affected by a fairly deadly tornado outbreak on the middle of the night, March 2nd and 3rd. And so tornadoes moving from west to east struck Nashville. We had an EF3 tornado in Nashville and Mount Juliet. Then an EF4 came here just west of Cookeville, and about 25 people were killed. I think 19 of those were actually in the Cookeville area out here. And when a tornado strikes at the middle of the night, remember, you need 10 to 15 minutes to take shelter. Imagine if some of that time is eaten up by the fact you've got to get up first and, put some clothes on, get out of bed and all that stuff. So that's one of the factors that we had a higher death rate here. And this was also the 6th costliest tornado in U.S. history. So $1.607 billion. So that cost the community a lot. That cost a lot of money. So that gives a little bit of awareness to the threat of tornadoes we're facing. I did want to give a shout out to a business that is very instrumental in responding to disasters, and that's the pizza machine. The pizza machine is actually a mobile pizza kitchen. They're built out of the back of an old school bus. And so they routinely park here in Cookeville. They're often at Red Silo Brewing Company in the west end of Cookeville. They have 3 buses. Pictured here is Pizza Machine 2 and Pizza Machine 3. Pizza Machine 3 also has calzone, which is really good. Now, the other nice thing about Pizza Machine is they have no price. When you go to buy a pizza at Pizza Machine, you tell them what pizza you want, they make it for you. They don't charge you for it. They accept any donations. So basically the price is whatever you feel the pizza is worth. In the aftermath of the tornadoes, they were able to park their buses right there where most of the people were affected by the tornadoes, and people's kitchens were destroyed. They were able to give them food right there. This past fall, when tornadoes moved through East Tennessee and Western North Carolina, the Pizza Machine went out there. When people didn't have power, they were able to provide pizza, hot meals for people in need. So they do a great job of responding to the storms and helping out the community. So if you're ever in Cookeville, give a shout out. If you're ever in Cookeville, just kind of stop by the Pizza Machine. Their pizza is actually pretty good. And if they're at Red Silo, you've got some beer as well too. That's also pretty good. So that's the Pizza Machine. I hope you enjoyed this video, and so you can give this video a like if you found this interesting, and feel free to leave some comments in the comments down below. And you can also subscribe to the channel if you kind of like more videos like this and you want to see more of them. So thank you.